Chapter 3, Section 2.1, Part 2's video. There's a problem prior to this that is a television screen, and it's kind of worked the same way as this, but I figured to work this one because it's not as intuitive as the other one. So when you watch this, you'll be able to do the television screen one, okay? What size square can be inscribed in a circle of radius 8 inches? All right, we all know that squares have the same sides, right? All the sides are the same for a square. We know that. So if I come in here and I go, well, I'll just put me another radius right there. And so what you have is this is 8, and that is 8, and that is a right triangle, which makes this, guess what, guys? It's good old Pythagorean theorem, right? C squared equals a squared plus b squared, right? So you can get this. Basically, you can really do this right here by hand. You wouldn't have to need a calculator. So that's 8 squared plus 8 squared. So c squared is 64 plus 64, which c squared equals 128. Ladies and gentlemen, take square root of both sides. So c equals the square root of 128 would be 11.31, approximately 11.31. So the side of it would be 11.31. There you go. Right? Okay. So that's how that works. That's about as easy as I can make it. Okay. For this one, we're going to use the calculator. So we're going to use the calculator to let it solve. So we got to put this in y1 and this in y2, right? And see where they intersect. And we know we're going to have two answers because they said separate them by commas. So here we go. y1 and y2. Okay, so I'm going to clear all this stuff. Y equals clear. So we're going to put parentheses x minus 3 parentheses squared. And then 25 is in the other one. So let me double check that. X minus 3 squared and 25. Okay, so now that I've got these in y1 and y2, now we can just hit graph. And you can see how that's, you can barely see it. So what I want to do is kind of modify some things. I like my X's because it shows where it's going to cross on both of them. But I'm going to adjust my Y's, so I'm just going to hit window. And we know we're drawing a horizontal line at 25, right? So I'm just going to again put 40, and then at Y min put negative 10, and then hit graph. There we go. Now, we want to find this intersection as well as the other intersection. So what we're going to do is second trace. We're going to do this 2 times. The first time, we're going to move the cursor over and make it above it, right? I don't put it on it. I just put it above it or around it, okay? Enter, 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 and I get a negative 2. So one of my answers is, guess what, guys? Negative 2. So that's at negative 2. Now I'm going to hit second trace, do it again, and I'm going to move it over. Yeah, you got to hit it quite a few times here. All right, keep going, keep going, keep going, keep going. All right, back. There we go. Enter, 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 and it's at 8. So the other solution is comma 8. So those are 2 solutions per this particular equation, okay? Again, I've done this all on the calculator. You did not have to use any kind of algebraic rules. You got 2 sides to an equation, left side and right side. The left side go on y1, right side equal y2. Folks, you see where they intersect? That's your solution, okay? All right, so Cyril plans to plans to invest $4,500 in a money market account that pays interest compounded annually. Okay, so write a formula for the balance B in Cyril's account after 2 years as a function of the interest rate. Okay, so it's A equals P times 1 plus R raised to the T. That's compounded interest, just annually compounded interest, just simple interest, right? Now, so because they gave us this, they said 2 years and that this is B, and right in terms of that, we started out with 4,500, so it'd be 4,500 times 1 plus R raised to the 2. Now, what that's going to do is that's going to allow us to be able to come in and solve some things after they tell us the next question. So P is the initial amount, so that's 4,500, okay? And A is the final amount. So Cyril would like to have 6,250 in 2 years. What would the interest rate be? So basically, here's the equation, right? 6,250 equals 4,500. 1 plus R raised to the second power. So we've got to find the R. Now, I'm going to tell you this R is going to be small. It's going to be a decimal. It's going to be less than 0.5, okay? Because 0.5 as a decimal is really 50%. So, and you could probably make 0.2 if you wanted to, but we'll talk about that when we get to the calculator. But I just want to make sure that you understand that this interest rate is going to be a very, very small number as a decimal below 1. Okay. All right. So here we go. Clear this out. And we'll go y equals. So 6,500. Yes, I know I put that in y1. I put the other side in y2. Okay. 4,500. Parentheses 1 plus x, parentheses squared. X is the radius. I mean, not the radius, the interest rate. All right, so we're just going to hit, well, we are going to do one thing. We're going to do negative 0.2 to positive 0.5, and we're going to have it step by 0.1. Okay, just know that those settings are really good for finding interest rate problems because the interest rate's a decimal below 1, right, for a majority of things. Now, if we find that it's above 1, then we can change that. But right now, we're probably looking at anything that's probably a 5 to 15 to 20% interest, which is really a 0.05 up to 0.2. All right, so we're just going to hit graph. And then I'm going to hit zoom fit. And what that does is, okay, well, that's not going to, my window limits aren't going to make it happen, are they? So let's go to, let's just put 2, graph. And it's still not. Well, here, let me just do, let's just hit zoom 6. And then zoom 0. All right, so we know it's out past 10. So we gotta do a little bit of adjusting here. So I'm gonna hit 20, and I will move this up to 7,000. And because I know I got a horizontal line at 6,500. So I want to give a little bit of headroom for that. Okay, so this is the point that I'm needing. So second trace, 5, enter, 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 and 11.02. Now, just know, okay, what I was talking about a while ago, this is 11.02 as a decimal, right? If we're going to put this in as a percent, then I want you to kind of consider something. If I put this in as a percent, you got to multiply it by 100, right? Which would move this 2 places, so it'd be 1102%. So I'm not sure which answer they want. They may want 11.02, or they may want 1102. So either one of them. Now, why did I say earlier that the interest rate would be somewhere between 5 to 20%? I'd forgot that it's 2 years and not 10 or 15 years. Okay, so 2 years, it has to have a really high interest rate to make it gain from 4,500 to 6,250. Okay, so just kind of know that. All right. Okay, this will be the last one in section 2.1. A machinist wants to make a metal section of pipe that is 80 millimeters long and has an interior volume of 9,000 cubic meters. Okay, if the pipe is 2 millimeters thick, its interior volume is given by the formula. Pi equals r minus 2 squared times h. H is the length of the pipe, r is the radius. What should the radius of the pipe be? All right, guys, so we've got volume equals pi r minus 2 squared h. So they're going to give us all this information. They tell us that it is 9,000 pi if the pipe is 2 millimeters thick, then guys, that's really the diameter is 2, and we want the radius, so the radius would be 1. Well, now let me back up. Because we're going to be finding it. What would the radius need to be? That is 80 millimeters, and that's millimeters. Okay, so this is r minus 2 squared times 80. Because we've got a section that's going to be looking like this, right? So that's height, right? So they want us to find r, and the volume is 9,000, right? Okay. R minus 2, if the pipe is 2 millimeters thick, they're taking into account the sidewall of the pipe. So that's why the 2's there. So that's initially my brain went there. So what we're going to do is type this into our calculators. Okay, so let's go back and do it. So y equals, right? So that's 9,000. Okay, that's, let's see, pi r minus 2 squared times 80. So let's see that. That's second arrow there, pi times, is it r minus 2? Yeah, it is r minus 2. So it'll be x minus 2 parentheses squared times 80. I think that's right. Yep. All right, so what we're going to do is we're going to graph this. We're going to just leave the limits the way it was, except for one thing. We know that we've got a horizontal line drawn at 9,000, right? So what we're going to do is we're just going to go right here and we're just going to say 9,500. Not 95,000, 9,500. So let's hit graph and let's just kind of see what it does. All right, so it gave me a little bit of headroom up there by putting 9,500. I could have put 10. It would have shifted it down a little bit more. So if you want to look at that and kind of investigate it, you can kind of learn some things about your calculator. All right, so these are positive x's over here. these are negatives, so I can't have a negative distance, so I'm going for that intersection there, which would be second trace, 5. Okay, enter, 7.98. So the radius would have to be 7.98. Round it to the nearest thousandths, which would be tens, hundreds. Let's see, tens, hundreds, thousands. It'd be 3 places. So you go back and calculator, hit mode. Let's move it to 3. Enter. Second table, not table, graph, sorry. And then let's just second trace 5 again. 7.984. Okay, so we know that is that. Okay, well, that concludes Chapter 3's Section 2.1 Part 2's video.